Welcome, everyone. Thank you for joining us for today's webinar. My name is Lauren Kortbein, and I'm a marketing specialist here at GTT. Before we get started, there are a few housekeeping items I'd like to go over. To avoid any distractions, we have all participants muted. If you have a question or concern, please enter it into the question panel or send me a note using the chat feature to your right in the control panel. Tomorrow, we'll be sending a short email with the webinar recording, related materials, and contact information. If you would like the presentation, please let us know and we'll send you a PDF copy. We do want this webinar to be as interactive as possible, but because we have so many participants, if you have a question, please enter it into the question box in the control panel to your right, and we will address them at the end of the session. I'll bring them up as submitted at the end. If we don't get to your question or you would like to address a topic personally, please contact myself at lauren.kortbein@gtt.com, and I will connect you with the right GTT resource. We will also be sending an email tomorrow with the webinar recording, and that will contain our contact information. Today we are presenting Priority Control 101, Safer, Faster, and Smarter Vehicle Movement, presented by Liam Kearns, Solution Engineer here at GTT. And with that, let's get started with our webinar. I'll now hand the presentation over to Liam.
Hey everyone, this is Liam Kearns. Thank you for the introduction, Lauren. Today, as we said, we're going to talk about Priority Control 101 and kind of what that means. Rough agenda here, and this is a pretty light conversation. We're not going to go too deep in the weeds. We're going to start out kind of just talking about where the modern challenges that many cities are seeing today, kind of everyone from small cities up through large cities and everything in between. Then we'll move on to kind of what a solution of preemption priority control looks like and what even that really means from a perspective of what the actual technology does, what the result is, and how that works. We'll also talk about a service that we offer, which is called Priority Control as a Service, which is essentially a managed implementation, and then kind of talk about a little bit of the future webinar topics. So that being said, let's just jump right in. So what are the smart city challenges that we're seeing today? One of those is, of course, increasing congestion. I'm sure every single person watching this right now has a situation of increasing congestion in their city and in their service territory. So that is definitely something that we're trying to overcome through a number of different methods, and one of those is going to be talked about today. Also is multimodal expansion. So it's not just cars and buses anymore. We've got bikes, we've got scooters, we've got flying Ubers. And so how do we manage all of that within the city's existing infrastructure, something that was designed for a purpose that now is being co-opted for something else? We also have multiple stakeholders. So traditionally we had, of course, DOTs, we've got transit agencies, we have fire and police. But now we have even more. We have individuals, we have corporations, we have private companies, all vying for that same space and that same usage. Through all of this, we're experiencing that evolving technology. And of course, that's things like the scooters we just mentioned, but it's also true of things like communications technologies, computing platforms, IT, and even the physical components we're putting into vehicles or roadways today. And of course, all of this is bound by the biggest issue of all, which is going to be that limited budget, right? No city has unlimited money, no agency has unlimited money, and so how do we try to maximize our investment and our efficiency in the solutions we deploy? So to talk to that, I first want to go over a little of the background of GTT as a company and kind of why we're qualified to discuss this. One of those is that we have more than 3,100 cities in the world that have implemented GTT solutions, including 41 of the 50 largest U.S. cities. And that's not something we just did in the last year or two. This is a deployments that have been some as old as 50 years for deployments technology and actually iterating and evolving both with the requirements and new technology itself. Beyond that, we're also tirelessly working to create new solutions and to really push the envelope as far as what is possible from the perspective of technology and trying to reduce kind of that investment component while maximizing the technology and efficiency that we have already deployed. And then as part of all this, because we've been around for over 50 years and because we have solutions that are proven to be reliable, we see ourselves as providing total assurance, right? We view ourselves as a partner and not just a vendor. So we really want to make sure that everyone that works with us has success in their deployment. So just to recap that, like I said, we're installed in 41 of the 50 largest cities. For the last 50 years, that's over 180,000 connected vehicles and intersections around those 3,100 cities worldwide. So let's talk about the actual solutions, right? Let's start with signal preemption. So there's two things, of course, preemption and priority. So we'll start with the preemption side of it. So what happens with preemption is that Opticom, our solution, will send vehicle data as it's driving down the roadway. Once it's at an approach to an intersection, it will then communicate with the intersection through a number of different methods to make a request to that intersection for a preemption. In the case of the intersection, that processes that preemption and provides a call to the controller to actually initiate a transition to green. Now, in the case of preemption, what we're doing here is we're telling the controller that we have a high priority request to implement the green as fast as possible in the direction of travel related to that emergency vehicle. So we're going to try and get around any other phase planning that's going on at that controller, not just make a polite request for transitioning when possible. When we're talking about the solution here, what are the actual results of deploying a Opticom preemption solution? Well, one of the biggest ones is going to be an accident reduction. So we've actually seen up to 70% reduction in intersection accidents where you're deploying a preemption technology rather than going through without a preemption call. So this is really a hard, both cost saving, of course, but also a major increase in safety, both for the agencies involved and the city, but also for the individual private citizens that are going through that same intersection. Corollary to this is that does mean you also get on scene faster with these green light requests, so up to 25%. We've seen an increase in speed to on-scene times. And with modern technology implementations, we can do a minimal signal impact. So it's not like the old days where I request a preemption and it gives me a hard green for a fixed amount of time and interrupts everything else. We can actually work with the controller itself to dictate timings and help it recover back into a synchronized pattern as fast as possible. So to contrast that, let's look at signal priority control. So this is different than preemption. This would be something we typically see on, say, transit, right, in a bus or paratransit environment. So signal priority control, again, the vehicle is sending data as moving on the roadway, and once again, in a very similar fashion, on approach, a request is being made to that light. But what happens here at the very end is that the Opticom solution will verify that call, but instead of telling the controller that it needs a green immediately, it's going to request a priority call on that. And what that typically is implemented as in the controller is either an extended green time, so maybe adding 3 to 5 seconds to the existing green, or perhaps truncating the red to actually shorten the red time to transition it back into a green phase sooner. So unlike that, the preemption call where we're telling it I need green in this direction immediately, here we're saying I would like a green if possible. Is there a way you can accommodate it while minimizing the impact on the transit signal? The results we see from this on the left-hand side there from the TSP side is to minimize travel time, right? So we see reduce in transit delays at intersections by up to 40% with transit signal priority on there. And the thing on the right there, ASM, is schedule management. So schedule management, to contrast our priority request, is basically a way for us to intelligently ask the intersection. So rather than asking every intersection as we come through for a priority request, we'll actually dynamically change that based on a number of factors, things like lateness, passenger loading, what route you're on, and determine whether or not to actually request a priority call on that intersection based on those factors, which means in some cases, if I'm ahead of schedule or on time or I'm lightly loaded, I may not actually make that request, which means there's zero impact to the traffic signal timings. So that functionally gives us an increase in on-time performance by maintaining headway between us and other vehicles while also minimizing impact actually on the intersection. Together, these two components can increase ridership, of course. We've seen reported ridership increases as high as 10%. We also see a reduce in emissions. So that cuts greenhouse gas emissions by up to 30% and reduces costs. That minimizes fuel costs by up to 19%. And an interesting side note here is that it not only reduces costs from a purely gas or diesel or compressed fuel type solution, it also applies to electric vehicles because I'm not stopping or braking so much on electric propulsion buses. For example, by virtue of not having to stop at every red light, I get that extended green and can continue on with as little energy use as possible. So let's talk about deployment, and specifically, what does it look like to deploy in a smart city and what are the considerations? So when you're looking at what type of solution you want to deploy in a smart city, and I'm going to call all cities smart cities at some level here because everyone's got some amount of deployment in place for existing infrastructure. The things to consider, of course, is start with your onboard vehicle system. So when you're talking about the vehicle, whether it's a fire truck, a police car, a bus, whatever it might be, you want to go through there and see what computers do you have on board. Is there anything that you can reuse? Can we co-opt a computer to install a software-based solution? Do you have GPS already on the vehicle? Do we need to put in new hardware, for example, on there? You also then want to look at your intersection equipment. So what are your signal controllers that you have today? Are the controllers modernized? Do they have Ethernet capability? Do they communicate back to a central platform? Or are they isolated on their own? Do they have dynamic or adaptive technology within them? And then, of course, a big one here is actually whether or not your controller itself supports preemption or priority requests at that controller. That's not something you can take for given. You'll actually have to see controller to controller what it's licensed for, what its capabilities are. And then, of course, there's the control center or the ATMS center. So there you want to know whether or not you have an ATMS today, what the capabilities are of the ATMS. Is it purely a reporting platform? Can we actually make changes to timings on there? And maybe most important from consideration of preemption and priority, can we use that as a pathway to actually communicate to the intersection from a central location? There are capabilities to deploy a centralized software solution that will communicate to the ATMS without requiring any hardware at the intersection. So you want to definitely consider that, and then whether there's any other IT systems you want to integrate with. Whether you want to bring this data into a central data lake to actually do reporting on, or whether you need to deploy new hardware in your control center, that sort of thing. And all of this is kind of tied together by that very central part, which is the communications network. So for the communications network, really I'm saying that from all directions here. So not just at the intersection, do you have fiber, do you have cell, that sort of thing, but do you also have any sort of communications to the onboard vehicle systems? So the vehicle systems themselves, do they have cellular? Is it a single-use cellular only for a single purpose? Is it something that you can deploy on? Is it something that we need to add additional to? Is the cellular reliable? What sort of the data plans do you have on there? So those are all considerations that you want to take into account for this particular approach. When we talk about the stages of deployment for a smart city, there's a number of different phases that we see various areas moving through. And so the very far left of this diagram is kind of the legacy environment, right? So there's no V to X, which V to X is vehicle to anything. So that means you're just operating essentially in an isolated environment where every vehicle is just waiting for timer-based typically or basic sensing lights. There's no preemption, there's no communication, no data passing, no logging, reporting, that sort of thing. There's then, in that case, right after that, a late majority, which we would call agencies or areas that have kind of point-to-point infrared or sound-based technologies. So this is a case where you have some sort of vehicle communication, but it's largely one-way communication, typically based on environmental factors, things like sunlight, snow, fog, that sort of thing. And it's usually some sort of physical transmission medium like infrared or sound actually based systems to call for preemption at the intersection. From there, you have the early majority, which is going to be your point-to-point communications. That's kind of the current standard for deployment. So that's going to be things like a GPS-based system to dynamically determine position, heading, ETA, radio communication, so 2.49 megahertz radio communication at the intersection, or even central management. So in the case here, we're using your communication to the vehicles from a central platform in order to deploy down, say, updates to settings or configuration, or say firmware updates, but you're not using that for any sort of centralized passing of requests. From there, we move on to early adopters, which are going to be people who have an integrated software solution. So this is a case where instead of, say, using point-to-point, I'm actually going up to a centralized system, maybe cloud-based, maybe actually hosted at an agency, or it might be, and I'm using that as my communications medium, which allows more flexibility in deployment and capability than just using point-to-point because I have visibility beyond my physical barriers. And then, of course, you have the leading edge. So that's kind of all the upcoming bleeding edge sort of stuff that we're seeing, integrating multi-systems. So we're talking not just the priority preemption system, but integrating that with other external reporting utilities, external agencies, private companies, centralizing that data, making an interoperable solution between multiple vendors and multiple deployments, and doing a lot of data analytics on that. So that's kind of what the scale of deployment looks like. And you can move from the left to the right as fast or as slow as you're comfortable with, or as budget or capabilities allow. So when you talk about how you actually deploy the system, a traditional deployment would be something like where you purchase a series of hardware components, you install them into your vehicle or your intersection. Those communicate, they're owned by you entirely. If they break down or they need repair, you send them in for warranty. You buy new units as necessary, you scale them out, and at the end of the life of the unit, you either purchase a new set or migrate onto a different path. There's also managed type deployments where you will still own the hardware, for example, but you can contract out the services so that any part from the simple maintenance of it up through to the reporting can be contracted to a third party. And then there's something that's called what we're calling PCAS, or Priority Control as a Service. So in this case, it's an entirely service-based deployment, which may or may not include hardware, but all aspects of it, from ownership through to maintenance, through to optimization, through to all replacement and lifecycle evaluation, is done on a service-based approach. So rather than having to make a capital purchase, you just make a simple payment on a yearly, monthly basis, much like a cable bill, and have these services provided to you. It's kind of the fastest path to deployment. GTT as an organization offers all three of these, but I want to dive in on PCAS because that's kind of the newest approach in the industry. So Priority Control as a Service. When we're looking at this, one of the biggest components of this, or one of the biggest benefits, I should say, to interested parties is minimal implementation. So in several cases, there can be almost zero hands-on from the purchaser for deployment of this. It's basically a turnkey solution. You say, I want this, and it gets provided, rather than saying, I want this, and then you have to figure out how to actually implement it. As part of that, there's no maintenance involved with Priority Control as a Service because it's a service, right? So you don't need to have to go in and maintain your own units, to go and check them on any sort of schedule. You have to contract out or bring in your own internal staff to go maintain the system. As virtue of all that as well, it makes it easily expandable. Because the system is, again, as a service, if you bring on new vehicles, new buses, fire trucks, police cars, intersections, whatever it might be, you can deploy them on a one-off basis by just adding them onto your current subscription service. And then, of course, because the service, the performance itself is optimized. So we're providing the service to actually analyze the data, make sure the servers and system is running smoothly, and report on that behavior appropriately. And from the financial side, obviously a very important consideration, it's a $0 upfront cost. So you're not talking about a capital purchase. This can actually get rolled into, say, a maintenance and an M&O or O&M budget, operations maintenance, for just a yearly recurring fee, and it's a predictable fee, right? So it's not like in the case when you purchase hardware outright, and if you have any sort of thing fail, I'm sure many have had to go back and buy a brand new piece of hardware for something. That price can be kind of random at some level because of various things like inflation or the part's been discontinued and so forth. But in a service type plan, there is no unexpected change to the cost. It is an all-in subscription plan, which means that everything is included in there. There's no having to kind of piece out or pick and choose what you want or don't want in there. It's all set in for you. And it's right fit pricing, which means that it's really sized to what you need and nothing you don't. You're not paying for 30% more than you'd use. You're getting exactly what you need and scale that up as you need it. So that kind of closes up the discussion there, just kind of Priority Control 101, some of the deployment methodologies, some of how it works. What I really want to briefly touch on here is some of the future topics we plan to cover. If this has caught your interest, we want to dive in more. And so coming up here, we've got several focused webinar presentations. One of those is Centralized Priority Control as a Service. That will be on October 10th. We also have Advanced Transit Signal Priority, which is going to be on October 24th. We have the Migration Paths, which is a discussion on legacy IR to next generation migration. That's October 31st. And then on November 14th, we'll have interoperable systems for smarter mobility. And with that, just to recap, GTT can change the way your city moves with smart city mobility solutions. There are multiple flexible methods of system deployment. Interoperable solutions will maximize your existing and future investment, and cities see a quantifiable increase in quality of services with GTT solutions. So at this point, I'd love to take some questions if anyone has any.
Awesome. Thank you, Liam. Like you said, we'll go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the question box in your control panel to the right. So it does look like we have a few questions here. Liam, I know you've covered some of this, but I'll review the questions that have been submitted. First, we have what types of technology are commonly used for preemption and what seems to be the most popular currently?
Certainly. So when it comes down to preemption technology, because the solution has been around as long as it has, really the most common, just by simple deployment numbers, is going to be infrared. Not everyone has the capacity to rip out an initial investment they've had for 40 years and replace it with something, newer. So that still remains by number the most deployed. However, the most common today when you're talking about new deployments or updated deployments is going to be kind of a combination of GPS and 2.4 gigahertz radio. So that's going to be pretty contemporary. And then, of course, we're seeing sort of the beginning edge of people using truly centralized solutions where they're using software-based only deployments to vehicles and to intersections.
All right, so next we have, how can the turnkey solution require no capital if existing traffic signaling systems aren't smart connected?
Yeah, great question. So the turnkey solution, or what we're terming priority control as a service, is inclusive of all of whatever is required to actually make it work as far as the GGT priority and preemption hardware and software goes. So in cases where the intersection controller doesn't have communications up through the network, we'll actually provide connectivity to a central solution, and we'll also provide, if necessary, hardware cards to actually do the conversion from a priority preemption request to an actual signal call at the intersection. Great.
So next we have, can you do priority control beyond fire trucks and buses?
Great question. So fire trucks and buses, of course, are a big portion of the system, but we are also capable of expanding the system to accommodate things like paramedics, snow plows, paratransit. Really, the sky's the limit as far as vehicles go. And so to that end, we can prioritize relative to each other, which means, for example, if you give buses and paratransit on the transit side priority control requests, and you also gave something like a snowplow, we can prioritize a snowplow over a bus, for example. Or we can prioritize fire trucks over, say, paramedics, or however you'd like to do that.
Great. So then we have, how do you distinguish between priority, between emergency and transit?
Yeah, so emergency uses the preemption call, as we were talking about before, and transit uses the priority call. The difference there is actually from a physical implementation. If you're talking about traditional deployments, they actually use a different signal at the intersection. In modern systems, they use actually a different protocol. So if you're familiar with NTCIP, they use 1211 for priority, and they use 1202 for emergency preemption. But in our system, we handle all the complexity of that. So when you put in a unit into a vehicle, or you define a vehicle in a software solution, we'll define it as a higher or lower priority vehicle for you, which helps differentiate that in the field.
So then we have, if my city is already using IR, what is the best way to update?
Good question. We can definitely help with that. It's kind of a discussion, really more than it is a simple, straightforward answer. But I do want to mention that on October 31st, there is that webinar on the conversion from IR to future technologies, so radio and centralized, and they will definitely discuss the kind of the finer points of that in that session. If you can't wait for that session, or you're going to miss it, feel free to give us a call, and we can walk you through that process. Great.
So then one other question we have, can I work with other cities for their preemptions?
Yeah, excellent question. So we do have many cities that have mutual aid capabilities in their system. There's a number of ways to go about it. With 3,100 city deployments out there today, there are many cities that have neighboring areas that use some form of our technology, whether it's kind of the more legacy IR technology, or it's GPS, or even centralized systems. We can definitely work with you on setting that up. But basically the short answer is that you can do mutual aid configurations, whether or not your intersections have it. You can use it in other neighboring cities or vice versa.
Great. So I know we didn't get through all the questions, but we are running out of time here. So if we didn't get to your question, please contact us directly, and we'll be able to give you all the information you need. So Liam, is there anything else you wanted to cover before we wrap up here?
No, I think I'm all set. I just appreciate everyone taking the time out of their day today to have a conversation and sit and hopefully learn something.
Great. Well, thank you again, Liam. Thank you, everybody, for attending today. We do appreciate you being here. Again, we'll send out the recording and related content tomorrow. If you have any further questions or interests, we do encourage you to contact us directly, and we'll arrange a time to speak to a GTT resource. Thanks again for joining us today, and have a great day.